So again, we're going to look at solving systems of equations algebraically. So what we have is we have two graphs, two y equals mx plus b type graphs that we're going to solve for to find where they intersect. I know we've gone over this lesson before, but we're going to do it again just to make sure we got it because I got a big hunch on this one. So a system of linear equations is where two or more lines or linear equations use the same variables. That would usually be x and y. And they end up crossing each other. So if a system of linear equations is going to have a solution, then it will be the ordered pair. It's a set of coordinates, an xy coordinate of where they meet. So we'll be looking at graphs of linear equations to find out how to solve them, and then I'll send you a worksheet on how to do it. So as you can see, these are parallel lines. They do not meet, they never will meet, they do not have a solution. So because of that, no answer or no solution is your answer for that one if you graphed it out and found out that they were parallel. So they're parallel because they have the same slope. And we'll look at that later on when I give you a couple of examples. They have the same slope, but they're not the same line, then they are parallel and there is no solution. This one, on the other hand, is a correct answer because, or this one is one where you do have a point where they meet. And that point would be 4, 3. Now, to actually get to 4, 3 on your graph takes a little bit of time, and there's a couple of ways to do it. Sure, you could graph out both of these and try to find out where they do, or what you do is you do some elimination to try to find out the exact point where they meet. So here's how to graph and solve linear equations. Systems of equations, one way you can do it is you can graph them out. Using the graph to the right, we can see any of the ordered pairs will make the first equation true, since they lie on that line, as you see. And then we do the same thing for the second one. We can see that any points, see if any of those points will make the second equation true, but there's only one point where they meet. This is the one coordinate, so set of points that make both statements true. The point where they intersect makes them true at the same time. So let's look at these two equations. And they've written them out in standard form, x minus y equals -1 and x plus 2y equals 5. We always need to verify that both coordinates actually satisfy the conditions. So to do this, what they did is they actually picked the point 1, 2 and plugged it into both formulas. So 1, because 1 is the x coordinate, 1 will go where x is in both of them. 2 will go where y is in the both of them. So 1 minus 2 is -1. That checks off. That's good. Put my 1 for x, my 2 for y. 1 plus 2 times 2 is 4. So 1 plus 4 is 5. That makes that true. So as they are, boom, there it is. So graphing to solve a linear equation, sure, you can graph them, and that's fine. There are different ways to graph these equations. I like the slope-intercept form too. The PowerPoint I got this from likes to do that also. To put the equations in the slope-intercept form, first we have to solve for y. Now this is important. So we're going from standard, we're going back to y. So we start with 3x plus 6y equals 15. We subtract 3x from both sides, and when we do, we have a negative 3x over on that side, and then, so we're right here right now. We've subtracted 3x from both sides. That gets rid of the 3x on this side, so you have 6y equals negative 3x plus 15. Now we have to get rid of that 6, so we have y equals. That's the key thing here. Divide both sides by 6. Negative 3 divided by 6 is -1/2. 15 divided by 6 will be 5 over 2. Similarly, we could have added 2x to both sides, then divide everything by 3 to get the second equation. So we could use this equation to solve for y also, and that would be 2/3 x minus 1. Now we can graph them if we wanted to graph them, and this is one way to solve. So we graph them out. We use the x-intercept and the slope. So on the first one, your x-intercept, remember, is the number all by itself, and that would be 5 over 2. So 5 over 2 is 2.5, really. So y-intercept's 2.5, and my slope is negative 1 over 2. So I drop down 1 and go over 2. That's that right there. The other graph is this one. And this one, the y-intercept is negative 1. Boom, right there. And my slope is 2, 3. So I actually go up 1, 2, and then over 1, 2, 3. And it just so happens that gives me this point 3, 1, which I know on this line is where it is, but it looks like it satisfies that one. So if I plug that 3, 1 into both formulas, 3 times 3 plus 6 times 1 gives me 15, and negative 2 times 3 plus 3 times 1 gives me negative 3, then our solution is correct, and that's all we need to do. But that's a little time consuming, and sometimes it's a little tougher than that. So the better way to do it is, instead of trying to estimate where the graphs intersect, let's simplify by eliminating. And let me show you how to eliminate in case you don't remember, or to substitute. So when given two equations, solve the equation for one of the variables. Solve for x, solve for y, whichever one, then take the other equation and substitute it in. And then you solve. And I'll show you how to do this in case you don't remember. So 2p plus 3q, and they use p and q here instead of x and y, but it's the same thing. So we have 3p plus 2p plus 3q equals 2, and p minus 3q equals negative 17. So with that, we're going to pick this one because we'll solve for p, because solving for p is going to be really easy. All we got to do is add 3q to both sides. Then we'll take what we solved for as p and plug it into the first formula. So now we don't have p anymore, we just have q a couple of times. So it goes like this. P minus 3q is negative 17, so I'm going to solve for p. So I added 3q to both sides. Now I have p equal to something. It's negative 17 plus 3q, or you could have said 3q minus 17. Same answer. Now that we know that, what we have for p, we plug that in right here, where this p is, so that it's no longer p, it's now negative 17 minus 3q. But I have to multiply that times p. Let me show you. So here's my first equation. We know that p is equal to this, so we're going to plug this into p. So there it goes. Boom. Magic, right? Now, instead of saying 2 times p, I say 2 times whatever was equal to p, and that was negative 17 plus 3q. And then the 3q plus equals 2 just comes along for the ride for now. Now I'm going to distribute. Let's say 2 times negative 17 and 2 times 3q. Well, 2 times negative 17 will be negative 34, and 2 times positive 3q is 6q. Plus the 3q equals 2. Now I can combine my like terms here. So when I do, I've got 9q, because 6 q's and 3 more q's, and then I add the 34 to both sides to get rid of it on this side, because what I want at the end is I want q equals number. So now what I have is 9q equals 36 after I add the 34 to both sides. So now I just divide both sides, and you divide both sides by 4. You divide by 9, and you get 4 as an answer. So whenever we substitute in for p, q will be 4. So now all you do is take that q, take that 4, and sub it back into the value of one of these two formulas to solve for p. So let's do this second one. P minus 3q is negative 17. We know that q is 4, so we'll plug 4 in here, so it'll be negative 3 times 4. So that's exactly what we do. And when we do that, we solve it out, and p will now be equal, because we say negative 3 times positive 4 will be negative 12. Negative 12, I got to get rid of the negative 12 because I want p equals number. So I have negative 12, so I add 12 to both sides. When I add 12 to both sides, it gets rid of the 12 on this side, and I'll say negative 17 plus 12. Negative 17 plus 12 will be negative 5. So my coordinate now is q will be p, q will be 4, and p will be negative 5. So you always write it in ABC order. So it'll be negative 5, 4. Yet again, with m and n, we usually use x and y. I don't know why they used this one in this example, but they did. But the same results. So pick one out, solve it for m, or solve it for n. And that's what we're doing. We're going to solve for n. So to solve for n, you just subtract 2m from both sides. Now that you have something equal to n, now you plug it into the other formula. So m minus n now becomes m minus 10 minus 2m equals 2. And that's exactly what we've done here. Since this negative is on the outside, that means negative 1. Negative 1 times 10, and negative 1 times negative 2 will be positive 2. As you see. So now we have m minus 10 plus 2m equals 2. So 3m equals 12. Because what we've done is we've added the 10 to both sides to get rid of the 10. And we've said m plus 2m. So that's 3m equals 12. Now we just divide both sides by 3. And we get 4 as an answer. Now we have that. Now we plug that 4 back into, let's say, this one. Because this one is the easier of the two. So 4 minus something gives me 2. Well, that's 2. 4 minus 2 gives you 2. That one's pretty easy. They use the other one. They plug in the 4 here. 2 times 4 is 8, and 8 plus something gives me 10. Well, that's got to be 2. So that's your answer. So in ABC order, m will be 4, n will be 2. So 4, 2 is your answer. So we're going to do it one more time, or 2 more times right here just to make sure. We already have it solved for y. So y is negative 2x plus 1. So instead of saying y in this second problem, we're going to say negative 2x plus 1. So when we do, now we have negative x plus 2 times negative 2. So we plugged in the y. Negative 2 plus 1 equals 2. Now we distribute that 2. 2 times negative 2, 2 times positive 1. Ooh. The error is a little off on that one. Sorry, folks. And so now we have negative x minus 4x plus 2 equals 2. So now we say negative x minus 4x. I lose 1x. I lose 4 more x's. I've lost 5 x's. So 5 x's plus 2. Now I've got to subtract the 2. And then I'll subtract to the other side. It'll be negative 2. 2 minus 2 will be 0. So 5x minus 2 is 0. Uh-oh. So now we have negative 5x is equal to 0. If I divide both sides by negative 5, guess what? It's still 0. So if x is 0, then I plug my x back into the other formula. And when I do that, I'm going to plug that 0 in right there. So negative 2 times 0 is 0. 0 plus 1 is 1. So that's your answer. So your xy coordinate is 0, 1. And that would be right there. So if I graph that one out and graph that one out, as you see, the coordinate where it crosses is at 0, 1. Ta-da! Let's do another one. Negative 2x plus y equals 13. And 4x minus 3y equals 11. First thing you have to do is you have to solve for y. So I'm going to solve for y in this first one because it's a little easier. So what I'm going to do is I'm going to subtract 2x from both sides. That gets rid of the 2x over here. That makes it a negative 2x plus 13. So y equals negative 2x plus 13. Now that we've solved that, whatever we have for y in the second one, we substitute what we have here for y. So 3 times negative 2x plus 13. Just like that. So now we have 4x minus 3 times negative 2x plus 13, because that's what we found out y was equal to, and that'll equal 11. Now we just multiply out. I don't know why those arrows go that far, but they do. So we multiply the 3 times the negative 2 and the 3 times negative 3 times negative 2 and negative 3 times positive 13. And so what we have is 4x plus 6x minus 39 equals 11. We can combine these two. 4x and 6x makes 10x. And we add 39 to both sides. So 10x minus 39 is 11. We add the 39 to both sides. And we have 10x is equal to 50. So now we divide both sides by 10. And when we do, we get 5 as an answer. Now that x is equal to 5, we plug it back into the other formula here, or into that formula, whichever one. So 5 times negative 2 is negative 10, and negative 10 plus 13 will be positive 3. So my xy coordinate is 5, 3. Just like that. So we'll do one more here. First, you got to solve for y, or this one they solve for x. Since they solve for x, you can solve for x. That's fine. Solve for x, go ahead, get x as an answer, and then figure it out. Since we've already done that, now we just put in, instead of x in the second problem, it's now 2y minus 7. So we distribute out. 3 times 2y will be 6y. 3 times negative 7 will be negative 21. And then the plus 4y equals 9. Now we'll say 6y plus 4y is 10y. And now we're going to add 21 to both sides. And when we add 21 to both sides, we get 30. So 10y equals 30. Now we divide both sides by 10, because we want y equals number. So when we divide both sides by 10, we get y is equal to 3. Since y is equal to 3, now we plug it back into one of these formulas. We're going to use that one. So 2 times 3 is 6. 6 minus 7 will give me negative 1. And there it is. So my xy coordinate will be negative 1, 3. Doesn't matter which one you solve for first, as long as at the end of the day, you put your xy coordinate in alphabetical order. X comes first, y comes second, and that's it. And this will be the last one. Same process, solving for y. So to solve for y, you add 2x to both sides. Add 2x, add 2x. So 2x minus 5 is equal to y. So in my other problem, instead of saying y, we're going to say 2x minus 5 as we substitute it in. So instead of y, we have 2x minus 5. So 6x minus 3 times 2x minus 5 equals 15. So we distribute it out. Still don't know why those arrows do what they do, but they do. So 6x minus this 6x equals 15, or plus 15 equals 15. Interesting. So now we say 6 minus 6, which gives us 0, and 15 equals 15. Uh-oh. So we're out of letters. We don't have any more letters. So this means there's an infinite number of solutions. Because if we were to solve both of these out, so we got this y equals 2x minus 5 for this one. So let's look at this one again. This other one, same process. If we solved for y, we would first add the 6x to both sides. I added the wrong one. But I put the 6x over there and then divide both sides by 3. And when I did that, guess what? It's the exact same line. Both, when you set them equal to y, both are 2x minus 5. Y equals 2x minus 5. Because they're both y equals 2x minus 5, they are the same line. That means all solutions are the same because they're the same line. On the other hand, if you solve one out, and we see this one is y equals negative 3x plus 1, we substitute it in like we've been doing, and we get 2 is equal to 5, but that's not right. Why is that not right? Here's why. Because here's your first formula, this y equals negative 3x plus 1. If I take my other one and solve it for y also, I get y equals negative 3x plus 5 over 2. They have the same stinking slope. Negative 3x, negative 3x. Different y-intercepts, positive 1, positive 5 over 2. That means they're parallel. If they have the same slope but different y-intercepts, they're parallel to each other. That means they never actually intersect, so there is no solution for that set of formulas.